Hi, so I have something a little different on the board. Here today we have a function x squared plus 1, which I've graphed. And what we're going to do is we're going to try to estimate the area under this curve using the Riemann sum. And this is actually a introductory topic before integral calculus, which kind of builds up the intuition, like the understanding of integration. So and that's why you'll notice when I do this, I've got an excessively simple example, and I'm not focused on the calculation, but more on the idea behind it. So the idea behind the Riemann sum is basically to take a curve like we have here and then break it up into simple geometric shapes that we can calculate. Like here I have three rectangles, okay? We have three regions. This rectangle, and this rectangle. And from geometry, we know how to calculate a rectangle. So we can clearly calculate an area of this, and obviously it's not gonna be a great estimate of this area. We want the area under this curve. So we have this curve here of x squared plus 1. And then we want to calculate all of this area below. And we're given to calculate this, we want this, I should write here, this is on the interval 0 to 6, which I have on the number line here. So we want to calculate that area, and we have this very kind of broad way to calculate it with these rectangles, but you can see that by doing this we have a lot of excess, right? Like we have a over calculation, like especially here in this third rectangle, we're going to overestimate with all this area here above the curve. And this approximation here that I have here, this is actually, in this case, the right Riemann sum. The reason this is called right is because each of the rectangles is based on the right endpoint. So we have we've broken this up into three segments on our interval 0 to 6. So I just decided arbitrarily, because it's actually easier. So I just decided to break it into three rectangles. The more rectangles I broke it into, the more accurate, right? If I had very small rectangles, we would be getting very close to the area if we broke it into 100 rectangles. So with three rectangles, it's kind of clumsy and it's going to be pretty inaccurate, but it's still going to make the point. So again, so we call it a right Riemann sum because we're using the right endpoint of each interval for our height of our rectangle. So like for this first rectangle, from 0 to 2, we're taking the height to be the value of f of x at 2. So let's just get that. So f of 2 of x squared plus 1 is just going to be 2 squared plus 1, and so that's 5. So that point right there, this height is 5, and we're using that to estimate this height of the curve here, which is obviously changing and is hard to know precisely, right? That's kind of why we're doing this, is we don't know exactly what it is. I mean, yeah, we could actually calculate it at all these little points, but we're doing a broad estimate. So for this first height of the first rectangle, we're going to estimate with 5. Then next, again, using the right endpoint, right, the left endpoint, here too, the right endpoint for the second region is going to be 4. So we'll calculate f of 4. And that's going to be 4 squared plus 1 using our polynomial. And so that value is 17. So this height right here is 17. I don't know if you can see that. Then for our third rectangle, our right endpoint is 6, so we'll calculate f of 6. That's just going to be 6 squared plus 1 equals 37. So this height here of this big rectangle is 37. So then, calculating this estimate of the area, we have our height for each rectangle. We know our width, so we have consistent width, right? Each of these is 2 wide. So to calculate this area of these 3 rectangles, we'll just calculate them one at a time. So the first one is going to be width of 2 times height of 5, plus the second one, width of 2, height of 17. And then for our third rectangle, it'll just be 2 times 37. Is that right? Yeah. Okay, so let's just add that up. So we have 10 plus 34 plus 74, and that's going to be 118. And then in the next video, what we can do is we can, instead of doing the right Riemann sum, we can take the left Riemann sum, where our height is going to be based on the left endpoints, okay? And then we'll just get a different calculation. So we'll just see that there's different ways to do this estimate.